Hello everyone, welcome back to Mr. Lee's Math Class Videos. I'm Mr. Lee. We're picking up in section 6.4. In the last video, we saw about how the phase shift, or the horizontal translation for periodic functions, affects the graph. So now, vertical translations are a little bit easier. Whether you see it added at the beginning of the function or added at the end, this moves it up or down, depending on the units. A positive moves it up and the negative moves it down. When I make the table, it's always the thing I do last. So if you look at what's happening to the trig function, first off, you've got trig function, then it's multiplied, then something is added or subtracted to it. 4 is relatively basic, so I'm going to leave 4 for you to do because all it has is to the regular sine function plus 3. I'm going to look at one that has some kind of change on the inside of the trig function and the outside, as well as a vertical shift. And then on the next page, we'll look at ones that have all of the things, A, B, C, and D. So amplitude, period is affected, phase, vertical shift, and horizontal shift to wrap up the section. So first off, always start with the amplitude here. Also note that 2 minus 3 cosine 3x is the same as negative 3 cosine 3x plus 2. I sometimes find it easier to write like this, because knowing the trig function is the star of the show, and then what's happening to it, and then the adding or subtracting happens at the end. So here our amplitude is the absolute value of negative 3, which is still 3. So the negative just means it's a vertical reflection, so reflected over the x-axis is something that's an option on the online graphing, so make note of that. Period is 2 pi over the number in front of x inside the trig function, which is 3, which means the starting and ending point should only be 0, 2 pi over 3 apart. The phase shift, to find the phase shift, you set the inside equal to 0, 3x equals 0, x equals 0 when you divide by it, so there's no phase shift. But we also want to set the inside equal to 2 pi, and when we divide that by 3, you'll notice that the endpoint is 2 pi over 3. Again, the difference between these two should always match the period. This tells us that our starting value is still 0, but that our ending value is 2 pi over 3. So to find, this is our 0 and 2 pi equivalent. To find our pi in the middle, that's the average of those two. The average of 0 pi over 3 and 2 pi over 3 is pi over 3. Halfway between these two is pi over 6. And this one should just be pi over 2. Now what can you do if you're not sure about how to get these ones? You can always set 3x equal to pi over 2, 3x equal to pi, and 3x equal to 3 pi over 2. And solving for the x values should get you these other ones in the middle if you need it. So I'll start with the trig function, which is the cosine of 3x. Our first one should always follow the cosine pattern. Cosine of 0 is 1, pi over 2, 0, negative 1, 0, and back to 1. What is this cosine multiplied by? A negative 3. So negative 3 cosine 3x will take all of my y values and multiply them by negative 3. So negative 3, 0, 3, 0, and back to negative 3. But this is where that 2 comes into play. Negative 3 cosine of 3x plus 2 is going to add 2 to all of my y values. So that doesn't just affect the numbers, it also affects the zeros. Negative 3 plus 2 is negative 1. 0 plus 2 is 2. 3 plus 2, 5. 2, and then back to negative 1. So our actual coordinate points are 0, negative 1, pi over 6, 2, pi over 3, 5, pi over 2, 2, and 2 pi over 3, negative 1, and that should be where it starts the new cycle. So we can graph this. It only goes to the right for this period. And we can go by pi over 6's, because then that's pi over 3 exactly, then pi over 2, and 2 pi over 3. So it's perfect. We know off the top it has to go only down to negative 1, but it has to go up to 5. And then we just plot our points. So at 0, 0, negative 1, we're down here. At pi over 6, we're actually up at 2. Pi over 3, we're up at 5. Pi over 2, we're back to 2, and then back down to negative 1. So this is a cosine graph that's reflected over the axis. So instead of making the normal shape, it's upside down. But you notice it's off center. So the phase shifts made us kind of off-center from starting at 0. The vertical translations make us offset from the middle being at 0, and everything is shifted in that direction. So the graph isn't always going to match across the y-axis, and that's okay. So finally, we'll do a whole shebang, number 6, on the next page, and then I'll leave number 7 for you to try. All of the things happening at once. So let's note what they are. The amplitude here, so 2 sine of 4x plus pi minus 1. A is the absolute value of 2, which is 2. Our period is normally 2 pi, but it's divided by the number in front, 2 pi over 4, which is pi over 2. Our phase shift, again, we take the 4x plus pi and we set it equal to 0. We subtract pi to get 4x equals negative pi, and then over 4. So our phase shift here is actually negative pi over 4. And you can always tell by plugging this back in for x, it's what's going to make the inside 0. And we also want to set it equal to the normal ending point, which is 2 pi. When you subtract the pi, you now get 4x equals positive pi, so x here equals positive pi over 4. And actually negative pi over 4 and pi over 4 are actually pi over 2 apart. But it also influences our table. And then this minus 1 will just hang out until the end. But we've got a lot of table to do. So these are our x values. We start at negative pi over 4. We end at pi over 4. Lucky for us, halfway between these two is 0. Halfway between negative pi over 4 and 0 is negative pi over 8. And positive pi over 8 on this side. So we start with just the trig function, sine of 4x plus pi. Again, it's sine. We picked these, so these will be our normal quadrantal angles. We know sine starts at 0, then 1, then 0, then negative 1, and back to 0 at the end. This thing is multiplied by 2. Multiplying by 2 is going to give us still 0, 2, 0, negative 2, and 0. And then finally, it's the whole thing and then minus 1. So we'll take our answers from the previous line, subtract 1, so it'd be negative 1, 1, negative 1, negative 3, and negative 1. And this gives us our corresponding x and y entries. So we've got negative pi over 4, negative 1, negative pi over 8, 1, 0, negative 1, pi over 8, negative 3, and then pi over 4, negative 1. We're going to go by pi over 8s because that's how far I'm going out from 0 on either side, so that's going to make my life a little bit easier. So graphing this, it'll go positive and negative in both directions, so we'll kind of graph it. There's a little more in the negative direction than the positive, but here's 0, 0, so here we'll call this pi over 8 and pi over 4. Here's negative pi over 8, negative pi over 4. And here's 1. Do negative 1, negative 2, negative 3. And then from here, again, we just graph. Now, on your homework, again, what are you going to enter in? It's going to ask for the amplitude, the period, the phase shift, and it will ask for the vertical shift, which is our negative 1. So if it asks for the vertical shift, that's negative 1. And if there's a negative in front, you'll hit the reflect button. And it should, as long as you're picking the right sine or cosine button, do it for you. So negative pi over 4, negative 1 is about here. Negative pi over 8, 1, we're up here. 0, back down to negative 1. Wait, did I miss a point? 0, negative 1. Yeah, we're here. Pi over 8, we're down at negative 3. Sorry, just a sec. And at pi over 4, we're back at negative 1. So it's still the sine shape. It's just been moved a little bit. So like I said, I'll leave 7 for you to try, but of course I will put the key up. And that's really all for this video and all for Unit 3 in this class.